Hello and welcome to my channel Learning with Saritha. In this session, we will discuss the topic electric flux in uniform electric field. In an uniform electric field, the electric field lines are of same magnitude and same direction. And two, the electric field lines are parallel to each other and equidistant to each other. And for electric flux, we keep an area element in uniform electric field and some field lines will be crossing that area element, and that quantity of field lines passing through the area element gives the electric flux. That is, the electric flux depends upon the intensity of the electric field and the area vector. And for electric field, we know that it has both magnitude and direction. And what about the area vector? We must have a clear idea about the magnitude and direction of area vector. Here I have a rectangular element for area. Okay. What is the magnitude of this rectangular area element and what is the direction of this rectangular area element we are going to see here. For the magnitude, we have to take the product of the length and the breadth. Here I have a length value and here is the breadth. And for magnitude, we have to take the length into breadth value and it gives a numerical value, and that numerical value is nothing but the magnitude of this area element. Okay. We know that magnitude is just the numerical calculation. Okay, now we come to the direction. For calculating the direction, I have to take cross product of this length and the breadth. Both these are at an angle of 90 degree between them. Now we get area vector is equal to L vector cross B vector. And A vector is equal to LB sine 90 degree N cap. Here 90 degree is the angle between length and the breadth, and N cap is the unit vector that is perpendicular to the plane containing length and the breadth. That is, see here it is pointing outward, and here is the plane containing length and the breadth, and the unit vector N is pointing outward and it is at an angle of 90 degree to the plane containing length and the breadth. And for the value sine 90 is 1. So A vector is equal to LB N unit. LB is the magnitude of area and we can write A vector is equal to A N cap. N cap is perpendicular to the plane containing length and the breadth. Okay. That is, for magnitude of area vector, we take the numerical value only. And for direction of area vector, we have to consider the N cap unit vector. In this topic, I am going to place this rectangular area element in uniform electric field in different positions, and I am going to see how far the electric flux value is. For case 1, I am going to place this rectangular area element perpendicular to the electric field lines. Okay. That is, the electric field and the area element are perpendicular to each other. For this area element, what will be the direction for the unit vector? It will be pointing perpendicular to the area element. That is, this direction, the direction of the unit vector and the direction of the electric field are parallel to each other. That is, the area element is perpendicular to the electric field and the electric field and the unit vector are parallel to each other. For electric flux, we know that phi E is equal to E vector dot A vector and is equal to EA cos theta. And this theta we consider between E vector and N cap. What is the angle? Since they both are parallel, the angle is 0 degree, isn't it? Here E vector and N unit are parallel to each other. So the angle between them is 0 degree and phi E is equal to EA. And we can say maximum number of electric field lines are passing through this rectangular area element. So the electric flux is maximum when the electric field and the area element are perpendicular to each other. Here I have a rectangular area element that is placed perpendicular to the electric field line. Here is a source that is producing uniform electric field, and this rectangular area element, you see this element is placed in the field that is perpendicular to the uniform electric field, and this rectangular area element is perpendicular to the field, and the unit vector here, that is the unit vector for the area element and the electric field are both parallel to each other. Here you see the electric field line and the direction of the unit vector for area element are both parallel to each other, and so the angle between E vector and n cap is 0. For the next case, I am going to place the area element parallel to the electric field lines. Here are the uniform electric field lines and the area element is placed parallel to it. That is, electric field and area element are parallel. And what about the unit vector? The unit vector and the electric field will be perpendicular to each other, because for the area element the unit vector will be pointing upward in this direction, making an, that is, it makes an angle 90 degree to the area element and it is pointing upward. But the electric field lines are in this direction. Now what is the angle between E vector and n unit? We can say it is 90 degree. Now what will be the electric flux? Electric flux is E vector dot A vector, that is EA cos theta, and theta takes the value 90 degree and we know cos 90 is 0. So flux phi E is equal to 0. That is, no electric field lines are cutting through this area element. That is, electric flux is 0 for area and E parallel to each other. I have a source producing uniform electric field. Now I am going to place an rectangular area element that is parallel to the electric field line. Here you see the area element and the electric field lines are parallel to each other. Now what about the direction? The direction n cap is pointing upward, that is, it is perpendicular to the plane containing length and breadth of the area element, and the electric field line and the n cap are both perpendicular to each other. That is, the angle between the n cap and E vector is 90 degree. For the next case, I am going to place an area element that is inclined to an angle theta with the electric field. Here you see that the area element is inclined to the electric field. That is, the unit vector n unit is making an angle theta with the electric field. Here E vector must be resolved into components because there is an angle theta between E vector and n unit. So we resolve E vector into components, that is E cos theta along the theta axis and E sin theta which is perpendicular to E cos theta axis. Okay. So now we have to find through which component the electric field lines are passing. That is, whether the E cos theta and n unit are parallel or E sin theta and n unit are parallel. Here from this picture itself it is very clear that the E cos theta component and the n unit are parallel to each other. Okay. Now the electric flux phi E is E vector dot A vector is equal to EA cos theta. Here E we have two components, E cos theta and E sin theta. When we take E cos theta, we can write it as E cos theta A cos theta. For theta, the angle between E vector and n unit is 0. That is, they are parallel. So cos 0 takes 1 and phi E is equal to E cos theta into E. Now we give the component E sin theta. what will be the flux? Flux phi E is equal to EA cos theta and is equal to E sin theta A cos 90 degree, because here the theta angle is 90 degree. For cos 90 it takes value 0, so electric flux will be 0. Here what we understand, the component E cos theta, which is perpendicular to the area element, contribute the flux, and the component E sin theta, which is parallel to the area element, do not contribute the electric flux. Here I have a source producing uniform electric field and a rectangular area element is placed in such a way it is inclined to an angle theta. I will show the side view. You see the electric field lines are uniformly coming out of the source, and this rectangular area element is placed in inclined position, and you see that the unit vector n unit is inclined to an angle theta to the electric field lines. Since the electric field lines are pointing in this direction outward and the n unit is inclined to an angle theta, we have to resolve the electric field E vector into E cos theta and E sin theta. Okay guys, I hope that you all are clear in the concept of electric flux and uniform electric field. After watching the video, just click the like button, share my video and subscribe to my channel and travel with me to get full mark easily. Thank you.